Okay guys, welcome to AP Calculus, and this is topic 7.6. We don't do 7.5. 7.5 is Wheeler's method, and it's for AP Calculus BC rather, okay? It's not intended for AP. So, we have separation of variables. So separation of variables, and we do general solution. So we're gonna recall for implicit differentiation that in this case we're gonna solve implicitly, right? So what is the derivative of this now? We're gonna have 2x plus, okay, so 2x plus 2y dy dx is equal to 0, right? Okay, so which means what to do with this 2x, move this to the right side, and then the 2y is the divisor. So therefore we can say 2 or dy dx is equal to negative 2x over 2y. What cancels out is Alex Reyes and okay, so 2 cancels out, right? So our final answer would be dy dx is equal to negative x over y. This is for implicit differentiation. Okay, any question? This is just a recall of what we were doing last time on implicit differentiation. Okay, so this time we're gonna do separation of variables, but it's gonna be on general solution. So find the general solution of each differential equation. Can I move this up? Okay. So our concern is to separate the variable, meaning we can combine the x with dx and y with dy. What are we trying to do? Combine the x with dx and the y with dy. Okay, so that is the concept of separation of variables. We're gonna separate variables according to its, let us say, in according to its family, the family of x dx and x, the family of y dy. Okay, so what we do is we can apply here, we have dy so if we cross multiply, right, we can cross multiply, so we have y dy dx is equal to x squared. But what to do next is multiply x squared by dx. So we now have y dy is equal to x squared Okay, we have separated already, right? So x to dx and y to dy. So after that, after we separate, then we now introduce integral sign. That means both sides we take the integral. Do you get me? That's the next step. After we separate, we now write down the integration sign, integration symbol. So in this case, we can now integrate. Okay? So, do the antiderivative y dy, that means y square over 2. You get me? So on the left side becomes now y square over 2 plus we just write constant 1 because we have to do constant also on the other side, right? Okay, so on the left side we have constant 1, and how about the right side? It's gonna be x cubed over 3. Okay, so x cubed over 3 plus constant 2. Now I'm just giving you an idea because the next time we don't have to write all the time constant 1 and constant 2, but we just do it constant, okay, as only c. Do you get me? Okay, in this case, in order to eliminate constant 1, we're gonna have to subtract constant 2 by constant 1, and whatever is the result, we do it as constant 3. Okay, the result. So subtracting by constant 1. Okay, do you get me? We subtract both sides by constant 1. So this cancels out, and the result now becomes y square over 2 is equal to x cubed over 3 plus constant 3. But express constant 3 as just c, or constant. Did you get me? Did you get me, guys? Again, just express constant 3 as a mere constant, so an ordinary constant. So when I continue here, so we have y square over 2 is equal to x cubed over 3 plus c. Okay, then what to do now? You're solving for the y, right? So what to do with this 2? We're gonna multiply, but if we multiply or cross multiply by 2, c is not affected. You don't have to say 2c, but just leave it as c. You get me? So we say y square is equal to 2 times x cubed over 3 plus c. But as I said, you don't have to put as 2c. Okay, so y square is equal to 2x cubed over 3, just have c, not 2c. Okay, you might say, Mr. Roy, isn't it that we distribute? Yes, we are distributing, but the constant serves as constant, even if it's 1 million constant. Okay, just c. Are we done? Remember, we are solving for y. So what to do? This is a square, right? Y square, so we're gonna square root both sides. Do you get me? So our final answer would be y is equal to, if we take the square root on both sides, we're gonna have plus and minus, right? Plus and minus the square root of 2x cubed over 3 plus the constant. This is our answer, and this is general solution. Any question on number 1? Yes?
Why is it plus or minus square root?
You're taking square root.
Oh,
You take the positive and negative, okay? It is a square root. Because if we graph that one, we're gonna consider the top. Okay. Can I move this up now? Or can we discuss number 2? Are you guys done? Okay. So, for number 2, we have dy dx is equal to sine x and then times y squared. Now, to do this, we can now write as dy over y squared is equal to sine x dx. We separated already, right? Then what's next after we separate? We're gonna, what's the next step, guys? We're gonna take the integral. So in order for us to take the antiderivative of dy over y squared, we're gonna bring up the y squared. So what happens if we bring it up? That turns to negative. So we shall say the integral of y to the power of negative 2 dy is equal to the integral of sine x dx. And we can now take the antiderivative, right? Okay, so the power plus 1 over the new power, right? So meaning negative 2 plus 1 is negative 1. So we have negative 1 over negative 1. And then what is the antiderivative of sine? It's going to be negative cosine, right? So in this case, as I said a while ago, for the sake of discussion, I'll do constant 1, constant 2. But for us to make it fast, we don't have to show that one. We can just have plus constant on the left side, right side. Okay, so we have negative cosine x plus the constant. So what to do with this? Bring it down. Okay, so if we bring this down, this becomes now negative 1 over y is equal to negative cosine, right? Okay, guys, it's a negative cosine of x plus the constant. Okay, they are both negative, so we can divide by negative, so that turns to positive, right? So can I continue right here? So we now have 1 over y is equal to cosine x plus the constant. But again, we are solving for y, so what we do is we're gonna reciprocate both sides, the left and right. You get me, guys? So final answer would now be y is equal to 1
over
cosine x plus the constant. Any question? Hey guys, done? Guys, listen to my discussion. Don't be too dependent on the flip mat, okay? Just close your Chromebook, please. listen. It is in listening that you will learn. Close your Chromebook, please. You can see. Who has a good vision? Chris, you have a good vision? No? How about Brayden? So you can
Alex
switch.
has.
You can move right there for a while. You can stay there so you can see. Okay. So moving on to number 3. So can you separate now number 3? Again, x with dx, y with dy. How to do it? Could anyone tell me? We're gonna have dy. What is that, Josue? dy. Huh?
As dy over y
dy over y. Very good.
equals to x.
X dx. So we separated already, right? So what's next after we separate? We now write integration sign. So we can integrate. So I'm gonna rewriting this into the integral of 1 over y dy. I can rewrite it that way. Make sense, guys? So what is 1 over y? Ln y, right? Okay, so this is equal to the integral of x dx. So we now integrate. So you said that this is ln absolute value of y, right? Here, guys, 1 over y natural logarithm. And then what about this one? We have x squared over 2 plus the constant. Okay, how to get rid of natural logarithm? What we do? We e both sides, exponentiate both sides, right? In order to eliminate the ln. So we e both sides. So this is equivalent to 1, right? And what's next? You can have y is equal to e to the power of x squared over 2 plus the constant. And then what to do? Sorry. Plus the constant. Now, the constant should be written before e. Okay? So our final answer, can I write the final answer here? So y is equal to c and then e to the power of x squared over 2. That's how you write.
Mr. Roy is supposed to come here to add the c and e.
We are not adding. Remember exponential, the law of exponent. If it is addition, what to do? Compress that into multiplication. You get me? This is exponent. Please recall the law of exponent. This is now in compressed form. This is still expanded, right? So you're gonna compress that one from addition to multiplication. Do you get me, guys? Algebra 2 lesson. Okay.
And since we're not solving for a specific, it's just that.
Yes. So this is general solution, right? So your question a while ago specific, so that's particular. and that would be on topic 7.7. We are solving for a particular solution. This time 7.6 deals on general solution. Clear? So moving on to number 7. So what to do for number 7? Now look at this. This has an x, this has an x, so we can factor out. You hear me, guys? We can factor out. So how to factor this one? Factor out 2x, right? Do you get me? So we are rewriting this first into dy dx is equal to 2x and then y plus 2. Is that clear, guys? Okay.
Yeah.
So what to do after that? Of course, we're gonna have to separate now the variable. So this right here, dy over y plus 2, and then we have 2x dx. We separated already. Okay. Questions so far before we continue? So we're done separating. So what's next? What's the next step? Right, the integration
Yeah,
sign.
integration.
So integrate. Okay, I'm gonna rewriting this first. So this is 1 over y plus 2 dy. Very good. Okay, and then equals the integral of 2x dx. So what is 1 over y plus 2? ln, right? Okay, so you now write ln of the absolute value of y plus 2 and then is equal to 2x
cubed.
squared
Oh yeah.
over 2. So
Square.
we just
Yeah,
write x
exactly.
squared plus the constant. Okay,
And
then
Exponent.
what's next, guys?
then e.
We exponentiate both sides. Do you get me? Exponentiate both sides by writing e and then e. So that means we only have y plus 2. So y plus 2 is equal to e to the power of x squared plus constant. And what we do next?
Subtract 2.
We're gonna
Subtract 2.
subtract 2. Okay, so which means y is equal to e to the power of x squared. Can we now apply the
Condense.
law of exponent? This is expanded form, so we shall condense.
So C E.
So we have c and then minus 2. Okay, so this time we do practice. Okay,
Yeah.
so there are problems in actual AP. Now, if it is differential equation, if the problem is all about differential equation, please always remember the separation of variables. You're gonna have to combine the x with dx and combine with y and dy, and then after combining, you're gonna take the antiderivative. Okay. Can I move this up now so we can start the practice? So, what to do for number 1? What do you think we do, Tyler, for number 1?
Separate.
Separate. Then how to separate in that case?
Multiply by y. Multiply by y.
Multiply by y, and what else?
Get rid of the 3.
Or shall we do cross multiplication, right?
Okay.
So we multiply by y. So on the left side is y dy. And how about the right side?
3x squared
3x squared
dx.
dx. Okay. So 3x squared dx. So, and we separated already. So what to do now?
Integral.
Take the
Integral.
integral. So can you do now? Can you continue? Okay. Continue by yourself now. And make sure when you take the square root, please don't ignore the plus and minus. Okay? Well, you have money.
It's like
2x cubed. Yeah, you're right. That's correct, money. So keep going. You do number 2, money. So antiderivative of y dy is y squared over 2. And then antiderivative of this becomes now x cubed, right? Because this is 3x squared, 3x to the power of 3 over 3, so 3 cancels out. So the left side is just x cubed and then plus c, and then you're gonna cross multiply by 2, okay? Who wants to show it on the board? Money? Okay. Shall we give Money a round of applause?
Don't worry about it.
Okay, that's correct. Shall we give Money again a round of applause? Thank you, Money. Anybody wants to do number 2? Yes, Josue. Okay, shall we give Josue a round of applause? I like this. I'm done yet. You're gonna have to stand and deliver, guys.
Oh look, it says Josue.
Yeah, Josue.
Dang.
I'll say this next time.
Okay.
Fabio built Bobby for this stuff.
Can I just like skip some steps? Or just have it like that? Do you want me to simplify it with?
If you want, just go right away. Are you sure you're doing that way? If you were right, it becomes 1 over y. You get it, right? You get me?
Whatever you want. Oh well, yeah. That's just, oh.
Okay.
Yeah. That's the same thing though. Negative 4.
Yeah, but you keep on bringing it down, up, down.
Okay.
why you have double integration?
It's okay, it's okay, it's okay.
I got it. I don't know if I did. Y is equal to E to the power of 8x cubed over
it's
3 plus
CE.
and plus C.
Remember it's CE.
Oh yeah, I forgot.
It's
C.
And then it's just like the integral of
Yeah.
AX squared.
I got hungry.
And then you eat it.
I swear, if you didn't get that, it was about to be violent reaction.
No, I'm not. I think this is curved Bixby.
Okay, shall we give Josue a round of applause? So final answer should be y is equal to c times e to the power of 8x cubed over 3. Okay? So guys, can you now collaborate with your partner to continue? Number 3, number 4. We have enough time, right? We still have like 21 minutes. You now collaborate with your partner. Continue working on practice number 3, 4, 5. And if you have questions, just let me know. Okay?